Hello everybody and welcome to episode 17. In this episode we're going to be improving our grass cutting. So at the moment we can attack the grass and make it just sort of disappear, which is correct and all, but it doesn't look or feel particularly satisfying. So we're going to make little shreds of glass, or hope not, of grass explode out of the plants when they're cut and come to a rest nearby and eventually sort of decay away. Just little grass particle effects, essentially. So there's a lot to get through in this episode for a relatively small effect, but it's not just for the plants, okay? What we're going to create is a modular system that can be used for any type of fragment that we want an entity to be able to drop when destroyed. So it'll be handy for things like pots later on. We want pots that we can smash, or rocks that we can throw and they like break into little pieces, or anything really that needs to break apart. And it's also going to include some code we will reuse to cause things to drop useful items that we can collect as well. So again, with the pots, when you smash them, or even the grass when we cut it, it might eject gold or whatever else, or item drops and things like that. We'll be using some of the code from this episode to do those things as well. So there's a lot of stuff for what will feel like a small effect of just getting grass particles essentially to come out of these plants when we cut them. But it is going to be very useful throughout our game, so just bear that in mind. Okay, let's get started. Okay, so the first thing I'm going to do is bring in the sprite that we're going to use for our plant when it gets broken apart. So I'm going to sprites, create sprites, import, and from my ARPG assets folder, I'm going to look for sfrag underscore plant underscore strip4.png. If you're using my assets, that is. If you're not and you want to know what kind of sprite this should be, well, look at it. It's pretty simple. We've got 4 frames of just little green shapes that look a bit like our plants, just way smaller. It's like a 7x5 sprite. Origin set to middle center. That's going to be important as well, because I think this isn't going to animate, because obviously if it animates it's just a bunch of random shapes. We're just going to pick a random frame to be each fragment of the plant, okay? So each frame should just look like a sort of random piece of the plant, alright? What we can also then do is like flip them horizontally or vertically when we make the object to give a bit more variety as well. So it's like 1 in 4 shapes, and then like that goes to 1 in 8 shapes if we flip them, and if we do flip them vertically, that's double again, right? Anyway, we're going to call this sprite sfrag underscore plant. Okay, sfrag for s for sprite, frag for fragment, plant for plant. Next up, we're going to make an object called oFragment. So I'm going to right click on object, create, call this oFragment. It's not going to have a sprite, so don't go quickly just assigning that to the sprite we just created. This is going to be the root object for all different types of fragments in the game. You remember me saying things like pots and rocks will be able to break into pieces as well. So this one object is going to handle all of those different types of fragment. First of all, I'm going to add the create event, and we're just going to establish the various different variables this thing is going to need. It's going to need a variable called bounce, which is 0, deteriorate equals 0. Don't worry too much about what all these do for now, although a lot of them are fairly self-explanatory. Z equals 0, the height and the z-axis, very similar to how all of our entities work with shadows and so on. SPD equals 0, speed. Frick, which is going to be friction, which is going to slow our speed down over time, so they sort of blow up, the fragments sort of explode from a point and then slow to a halt, and that frick is what's going to slow us down, just the opposite of acceleration really, right? Or deceleration. Image speed equals 0, because we don't want them to animate. Image index, which is what frame we're going to have, is going to be I random image number -1. Okay, so that's a frame between 0 and the number of frames -1. So in our 4 frame image, we'll get a number between 0, 1, 2, and 3. Last of all, and this is semi-optional, I guess. I like it. I think it looks good. I'd recommend doing it. We're going to get the collision map, okay? Just the same way as we do for the player. to collide with the grid, so too do we want our fragments to collide with that. We won't ever worry about fragments colliding with entities or anything like that. That's totally unnecessary. But I think it's worth at least having them collide with the collision grid, with like building walls and things like that. I think it just looks a little nicer if they don't like spread over building walls and stuff. So we're going to get the collision mask. So collision map equals layer underscore tile map underscore get underscore ID, open bracket, layer get ID, col, close bracket, semicolon. So this gets the ID of that layer, and then this gets the ID of the tile map that is on that layer, okay, just as we've done in the past for the player and all the collisions. Alright, okay, so that's the create event, but then we also want to declare some variables in the variable definitions box. And here you'll hopefully see a bit more, if you haven't understood already, the difference between variables that we want to declare in the create event and variables that we want to declare in variable definitions. The ones we declare here are things that typically start at 0 and are things manipulated by the object itself, away from the game designer essentially, and are just part of the internal logic. And in variable definitions we want to put in stuff that we can change on a per instance basis and also a per child basis, because we're going to have child objects of OFragment, like a fragment specifically for the plants, specifically for rocks and so on, that may have different settings that we want to apply. And numbers that we want to be able to tweak and change, like between different instances, different types of object, and so on, are what's going to go in here. We're going to have a few a few variables in here. So I'm going to add 5 of these, and we're going to have bounce count, which is going to equal 3 by default. I'll go over what these do in a second. Bounce speed, which equals 0.05. Bounce height, to equal 8. Deteriorate after 300. Deteriorate time 180. Okay, so these 3 variables to do with bouncing are going to be the numbers that determine how our fragments bounce on the z-axis. So when an object like a plant is destroyed, it's going to make all these fragments come out, and we're going to kind of give them a z-axis bounce, kind of a sine wave, or kind of like style like bounce, alright? Which is very handy just for giving, again, you're seeing a little bit of depth, having things kind of move up. And so certain types of objects just look correct when they, just look better when they like have a little bit of a bounce to them. Just makes them feel a bit more alive. But certain types of fragment are going to want to behave a bit differently. Alright, so this is why we've set up the variables in here to determine kind of how high they bounce, how quickly they bounce, and how many times they bounce. And these are just our sort of default settings that feel kind of nice for that. Deteriorate after and deteriorate time. Our fragment, we don't want these objects to litter the screen forever. We want them to eventually go away. So deteriorate after is a number of frames after which the fragment will begin to disappear. Okay, it will just fade the image alpha of it out over time. It will slowly get more and more transparent, and when it's fully transparent, we'll just destroy the object and kind of free up that memory. All right, and deteriorate time is how long it takes after it started to deteriorate. All right, so 180. 60 frames a second, that's 3 seconds essentially, right? So after 5 seconds we start deteriorating, I'm not very good at pronouncing that. After 5 seconds we start deteriorating, and it takes about 3 seconds to fully deteriorate. Alright, with all of our setup done, we can move on to the step event. So in here, I'm going to write if not global.game paused. Because we only want these things to do anything if the game is not paused, and also that's let's not just write in this tiny box. Let's make this bigger because we're going to have quite a bit of code in here. So assuming the game is not paused, first of all let's do the routine for our fragment bouncing. So if bounce count does not equal 0, because obviously if it does equal 0 we don't need to be doing any more bouncing, right? So if that's the case, bounce plus equals pi the constant pi multiplied by bounce speed. I think I mentioned sine waves as part of doing this. We're going to use a sine wave to basically tell us like how high, basically to get that sort of arc, that trajectory. If you can kind of remember a sine wave, kind of how it kind of flows. It's made up of big curves, which are very useful for us when we want to just, slowly ascend to a peak and then slowly fall back down again. Okay, just gives us a nice sort of feeling of lifting into the air. Sine waves and cosine waves, very useful for this kind of thing. And because of that, you may remember that like a full wave on a sine graph is 2 pi. Or rather, that's a full wave up and then a full wave underneath as well. Obviously, we don't want it to like go downwards. We're going to do a thing so we only keep like the upper parts of the sine wave. Well, actually, really simple, but we'll come to that in a little bit. But one like peak and then coming back down again. That is going from sine 0 all the way to sine pi to about 3.14, right? That's one complete loop. Okay, so this bounce variable, in fact, it might be helpful if I just bring up Paint here, is basically going to tell us how far into a particular bounce we are, okay? So each bounce is going to do something like this, because it's like the sine wave. Obviously, a regular sine wave, as I said, would kind of do this. But we are going to make it so it just does this instead. Don't worry too much about that for now. But bounce is going to tell us how far into this each one of these, whatever you call it, these bells that we kind of are, right? And each one is sort of a number between 0 and pi, right? And what we're going to do is once we've hit pi, we'll just set 0 back to, we'll set bounce back to 0 again. So then it'll just sort of repeat this cycle of doing a full bounce. And so by doing bounce plus equal pi multiplied by bounce speed, we can just pick a fragment of pi to say like how much percentage-wise of a full bounce we want to do per frame. Okay, and you remember the bounce speed is currently set to 0.08 or something like that, or 0.05, I think it was maybe. Yeah, 0.05. So that's 5% of a bounce every single frame. All right, and we can kind of use that to work out how long a single bounce would be, and so on, just a useful number. Then what we want to do is say if bounce greater than pi. So if we've come just to the end of this first bounce. If that's the case, we want to set bounce back to, close to 0, so we're just going to subtract pi from it, and so that will take into account any overlap as well. Say we went to, pi and a little bit. By subtracting pi, we keep that little bit, and it stays consistent. So we just remove pi from bounce, and we're going to multiply bounce height by 0.6, a magic number thrown in there. You might want to make this a variable, it's up to you. But basically this just reduces our bounce height every bounce. So instead of getting something that looks like this, we end up with something that looks like that, okay? And with each bounce, it gets smaller and smaller and smaller, because each one is 60% of the last bounce. All right, which is cool. We create, that's how an object might kind of bounce to a halt. Then obviously, so that we don't just bounce forever, we want to do bounce count minus minus, all right? So it'll keep looping through this until eventually it runs out of bounce count and then stops needing to process any of this each time. Finally, once we've processed how far into a given bounce we are, if we are bouncing, we want to set that z variable to be whatever it should be based on how far we are through a bounce. We've got a number between 0 and pi at all times now that tells us how far through a single sine bounce we actually are. So I can just simply write abs sin bounce close bracket multiplied by bounce height. Now the clever thing here with abs was to make sure that if we do because that's what a regular sine wave would look like, right? So if we were for whatever reason over a single unit of pi here, and we were at this value, it would be negative, and that's no good. But if we just do abs, that just returns, that makes any negative number positive again. So it actually turns a sine graph that looks like this into one that looks like that. Which I thought was really clever at the time, but some of you might already be spotting here that this doesn't actually matter, because as I just established, our bounce never actually goes over pi. So we will only ever actually have this value. I think that actually works without that abs in, so maybe that's just totally unnecessary. And I'm going to take it out for now. But I'm glad I at least left it in to show you guys, because that is quite a cool thing to be able to do if you ever need to in future create a sine wave that kind of looks like this and does a bouncing look. You can use sine to do that simply by putting abs on the start of it, because you turn all the negative portions of the graph into positive curves, right? And so the whole thing remains positive. But as I said, because we only actually technically go between 0 and pi, I don't think we ever actually need to do that. So yeah, I'm taking it out for now. Maybe I'll regret it. Maybe there's something I forgot about, and there's some other reason I needed to have that. I don't think there is. Running through in my head, I can't think of why we needed that, but it was just in my original script. but so there you go. Anyway, if bounce count is 0, then just in case we have any sort of adjusted z left over, we want to fix z to be 0. So I'm going to do else, in fact, just on one line, z equals 0. All right, so we either do this or we just set z to 0. Next up, we want our fragments to deteriorate. So I'm going to write deteriorate. Simply in this, I'm going to add a number to the value called deteriorate, which is just deteriorate plus plus. So we're just going to add 1 to it every single frame. And then if deteriorate, I struggle to spell it each time, let alone pronounce it. I think there's just a lot of the similar sounds in that word. Deteriorate. Yeah, I'm not good at that one. Anyway, if deteriorate greater than deteriorate after, I have to really take my time pronouncing it. So if that number has exceeded the number of frames after which we want to start deteriorating. If that's the case, then image underscore alpha minus equal 1 divided by deteriorate time, because you'll remember image alpha is a number between 1 and 0 that tells us how transparent or how much alpha is in the sprite, so how transparent it'll end up drawing, 0 being fully transparent, 1 being fully opaque. So if we remove 1 divided by deteriorate time, which you'll remember is 180, we remove 1/180th from image alpha every single frame. That means that 180 frames later, image alpha will have gone all the way from 1 to 0, and that's what makes that value work as the number of frames it will take to deteriorate after this many frames have passed. Okay, then we also simply just want to say if image underscore alpha less than or equal to 0, instance destroy, and then just get rid, 0 what? And then just get rid of that object. Next up is friction, just applying that fric variable, which you'll remember I believe is like 0. Oh, it's currently 0. Oh yeah, okay, so we just set it here. I'm kind of using magic numbers for this as well. You can go in and write some variables if you want, but because I'm swapping it between 2 potential values, I found it easier and quicker to just write these as magic numbers. It's up to you. So fric is going to equal 0.05. I don't know if I've explained magic numbers, by the way. What I mean when I say a magic number is when I just sort of write a number into the code like this, that I just sort of pluck from the air, rather than defining it as a variable that we like set up in the create event or in variable definitions or something like that. It's just a magic number that just does the magical correct thing that we've just stuck in the code and doesn't change, right? Generally not best practice to use, but sometimes they're either necessary or are just useful, and in my opinion this is one of those times. So fric equals 0.05, and if z equals 0, fric equals 0.1. That just makes them or 1, 0, just so you can see the difference clearer. It just makes them slide to a halt faster when they are on the ground, so you don't get so our fragments don't they move while they're in the air, but then they'll come to a halt much quicker once they've hit the ground, so you don't get really slidey fragments, and you don't get really like ultra stationary ones that just go a little bit and then move. Okay, gives us a nice balance by letting them move in the air and then move slower to a halt once they've hit the ground and stopped bouncing. Then last of all in here, we want to move. Okay, we're just going to use length dir x and length dir y to move this fragment in whatever direction it's been given. So x plus equal length dir x speed and direction, y plus equal length dir y speed direction. Okay, and those two lines will basically allow this thing to move in whatever direction or whatever speed we want just by supplying it with a speed and with a direction, which we haven't done yet, but you'll see how we come to that very soon. Okay, and then last of all, I said last of all a minute ago, but last of all in this last section, we're going to check for collision. Okay, again, this is kind of optional, but I think it looks better to have this. So if tilemap get at pixel, and it's really easy, it's one line of code, collision map, or two I guess if you count the one in the create event, x, y greater than 0, speed equals 0. Okay, so if there is a collision at wherever we currently are, just set speed to be 0. It's not even like a proper collision system, right? We're not like detecting a collision and then avoiding it like we normally would, or moving as close as we can. Just writing a super bare bones, you know, if we find a wall, just stop moving. Okay, so we'll overlap the wall like a tiny bit, but we won't just move deep into that wall or into that spot where we found a collision. Alright, there's no need here for a really complicated collision thing, it's just a really quick thing just to make things look a little tidier. Alright, and then speed equals max speed minus fric, comma 0. Alright, that's just going to make it so we actually apply that friction. So we set our speed to equal whichever is biggest, either what it is currently minus friction, or 0. That's just to make sure we don't drop below 0, but we reduce speed by fric every frame. And that is the logic of our fragment object. Okay, it gives us a bounce, a deterioration, a friction, and movement. Now we just need to make it actually draw, taking that z variable into account. We do that the exact same way we've done it in other objects. In fact, I'd probably grab it from like p entity. If I go to draw, yeah, just it's literally just this draw sprite ext section. I'll go over it quickly again, but I'll just copy and paste that in. Draw sprite ext, and then just using all of the basic values from that. We probably don't need to floor the x or y here either, and save ourselves a CPU cycle or two there. We're literally just using draw sprite ext and then all the default values. All right, so the sprite is the sprite index, the image is the image index, x scale is image x scale, and so on, right? All the same things. The only difference we've made is when we pick the x and y that we want to draw at, we subtract z from the y just to give us that height. And that's our complete fragment object. See if I can kind of give this a try. If we make a new object called oFragPlant, set its sprite to equal sFragPlant, and then make it a child of oFragment. We can probably just cover the room in a few of these. If I go to our village, go to the instances layer, and just plonk a few of these around, and then press F5 and run the game, you can see them just kind of bounce and also sort of randomly generate their image index. Oh, I forgot to do it, so we flip their image x scale as well, but I think it looks fine for now. You could do that as an extra step if you want to go into the create event of the fragment and do like image x scale equals like choose 1 or -1. That might, you know, flip them left or right. Screw it, let's do it. I'll show you that real quick just so you can see what it looks like. Image underscore x scale equal choose -1 or 1. I'll just so randomly pick between those two things. You can see some of these now are like facing the other way. Just gives us just a tiny bit more variety in our, because we only have like 4 frames it could be. Now we have 8 different images it could be, right? Okay, just like that, doubled our content. Game of the year. Okay, so you can also see here that if I wait long enough, the 5-second passes, and then 3 seconds later that you see they sort of dissolve away. All right. They don't go anywhere, you'll notice. Our speed isn't moving anywhere because they don't have a speed or a direction by default. We could test that out real quick just by doing speed equals random. Well, speed equals like 2, and then direction equals random 360 or something like that. Speed 2 might not be enough, but we'll see. Oh, actually, it's way too much. Speed equals like 1. And there's the spread out. Oh, the frick isn't anything either. Well, it should be. Try 0.5. Oh wait, speed. Sorry, we set speed. It should be spud. Obviously, that's not correct. Yeah. Okay, so they're moving a bit now. Let's set that up a bit more to 2. And you see them just sort of scattering out in a random direction. That's kind of the effect we're going to have when we break apart a plant, right? Alright, now I was going to have this episode contain both the fragments of the plant and the part where we make the plants themselves drop the fragments, but it turns out doing each of those things took quite a long time to explain, so I've decided to split this into 2 episodes instead of 1. Still, I think this like kind of long, slowish approach to building up the fragment system is worth it because the system is really cool and will allow us to make fragments of like any type of object and drop them from objects when they're destroyed really, really easily in the future. So we're doing a lot of work now to save ourselves a ton of work in the future. Before I go, I want to give a quick shout out to the following in no particular order. That's Bowser the Dog, Zinan May, Robert Churches, Rovan Darlin, Zephyr Flame, Daka Dondigo, Max M, Bertie T, Relentless Rex, Do What Doobie, Jason, James Siggins, Dark Rider 0318, James L. Anderson, Hare, Hyungjin, Rupinder, Rennie Dam, Scott Matthews, Leo, Pixel Mush, Tyler Hubble, Maria Celeste Oliveira Frailing, Arrow Barbarian, Cabbage Pants, Vilvertinen, Gilberto Cisneros, Figgy, Mark Burgess, John Harwood, Zach Collett, Goose, Caleb Franklin, Troy Mera, Alex Schenkel, Wilfredo Landera, Carter Green, Justin Adega, Julian Paul, and Kaiser Ho. Thank you all so much, and thank you to all of my patrons who enabled me to make this work. Thank you all for watching, and I'll catch you guys next time.